All right, in this video, we're going to look at the makeup version of the Buggy Lab. I have it loaded here in Microsoft OneNote. The Buggy Lab consisted of a toy car, and we measured out various distances with our meter stick. And then what we did is we timed to see how long it took the buggy to go those distances. So down here at the bottom, I've already put in the trial data for you. This is the data that you're going to be using for the lab. And if you notice, our distances go from 0.3 meters all the way up to 1 meter. And then I've got all the corresponding times there. So our first step is going to be to plot our data here on the graph. Now, every good graph is labeled. The axes are labeled. So our time is going to go here on the x-axis. We measure our time in seconds. And then distance is going to go on the y-axis. We measure that in meters. Okay. Now, I'm going to take the time. If you look up here, the times go from 0.78 seconds up to 2.47 seconds. So on my graph, I'm going to count how many boxes there are, and I think there's about 25 or so. I'm going to skip every 2 boxes and put a mark like this all the way across. Okay. And now what I'm going to do is I'm going to go ahead and mark the boxes. I could mark every single tick mark. I'm going to skip. So each one of these tick marks represents a quarter second. So I can label that as 0.5. That would be 1 second, 1.5. This is going to be 2, and then 2.5 and 3. Okay. Notice they're all evenly spaced out. That's very important. Next, what I'm going to do is I'm going to do the same thing, but I'm going to go with distance. So if you look here, our distances range from 0.3 meters to 1 meter. So I need to count the number of boxes, and I need to evenly space out my numbers. So this case, if I skip 2 boxes, I'm going to run out of room. So I'm going to make every single box 0.1. So this will be 1. Actually, let me do it this way. I'm going to skip 2 boxes, and each one will be 0.2. So that's 0.2, 4, 6, 8. That would be 1 meter. So this is 0.2, 0.4, 0.6, 0.8, and then 1. I could keep going. Like I said, you want to try to evenly space them out and have it take up as much space as possible. Some of the groups, when they were doing this, they ended up with distances greater than a meter. They put 2 meter sticks together. So like I said, you could space it out a little bit differently. The other thing I could do is I could skip 3 boxes and do the same thing. So let me show you what that would look like. So if I skip 3 boxes, that would be 0.2, 4, 6, 8, 1. As long as they're evenly spaced out. Okay. This actually looks like it's going to work a little bit better because it takes up more of the vertical space. All right. Now I'm going to go ahead and plot my data. So my first point is 0.5 meters, and then I'm going to 1.41 seconds. So 0.5 meters is right about, what did I say? The time was 1.41. 0.5, 1.41. So maybe like here. All right. The next point is 0.7, and it's almost 2 seconds. So like here. Okay. The next point is 0.3, and that's 0.78 seconds. So like here maybe. All right, and then 1 meter was 2.4 seconds, so almost 5. 2.5, I mean. So I'm going to put that dot here. All right, and then looks like 0.9 was about 2 seconds. So right around here. Okay, now the next step is to take a ruler or a straight edge, and we are going to draw in a trend line. So I've got my ruler here. I'm going to pivot this around. Oh, this thing's really, let's try this. See if we can get this to rotate. Oh, gotta use 2 fingers. Okay, so I'm gonna put one end on my 0, and then, like I said, I want to try to find a spot where my ruler goes through the middle of all of my points. All right, so now I'm going to draw in my straight line here. You want your straight line to go all the way across the graph. Okay. My next step is to find 2 points on the graph where my line goes right through the X and the Y grid lines. So if you look here, my point, where my trend line goes through those 2 spots. Okay, let me find another one. How about this one, this nice clean one right here? All right, so notice it goes right through there. Those would be good points. So my first point's going to be 0.5, and then this is 0.2. My second point looks like it's about, let's see, that'd be 2.25. And I would say about 0.87, maybe. Doesn't have to be super exact, but try to get it as close as possible. Sometimes when you skip like an odd number of lines like I did on the y-axis, it kind of makes it difficult to gauge. All right, so those are my 2 points. Let me give you an example of a point you wouldn't want to pick. So if you look here, let's see, so like right here, this is not a good point to pick because my trend line does not go through where the X and the Y meet up. Okay, it would be a little tricky to try to figure out what that point is. Okay, all right, so I've got my 2 points. My next step is to take those 2 points and I'm going to use them in the slope calculation down here. Okay, so I'm going to take the 2 points and I'm going to plug them into this formula right here. Okay, so I can rewrite these points as x1 and this is y1. So that's the first x coordinate and the first y coordinate. This would be x2 and this would be y2. Okay, so I labeled each x coordinate as either 1 or 2, and then I labeled each y coordinate as 1 or 2. All right. The second point is usually the one that's further up on the graph. So my y2 is 0.87, and my y1 is 0.2, and this is over, let's see, x2 is 2.25 minus 0.5. All right, so when I do this, I'm going to do this in 2 steps. Unless you have a graphing calculator or you're really good with parentheses, I would recommend doing the top line first and then the second line. So when I do the top line, I get 0.67, and this is going to be over 2.25 minus 0.5. This is 1.75. Okay. Now, the y-coordinates were the distance, which were given in meters, and the bottom was given in seconds. So this is meters over seconds. So now I'm going to do the top, so 0.67 divided by 1.75. This gives me 0.38, and my units are meters per second. Okay, I'm going to write this in the box here, 0.38 meters per second. Now, the next part. So we know over that distance that our buggy was traveling on average about 0.38 meters per second. So the challenge in the second part of this lab is taking your taking your velocity and your time and trying to figure out where the buggy would be at a certain time. So I've already given you the equation here. Distance is going to be equal to velocity times time. So I'm going to go ahead and plug this in. So my velocity is the average speed that we calculated up here. So 0.38 meters per second. And I'm going to multiply that by the time, which is 8.75 seconds. And when I do that, I get 3.325. My units are going to cancel here, so my seconds will cancel, and I'm just going to be left with meters. So a good approximation, like if we're rounding here, I would say this is going to be about 3.3 meters. and that is our distance. So what we did again is we took our average speed and we multiplied it by a time that I provided, and then that tells us where our buggy is going to be at that time. And that was the point of the Buggy Lab that we did in class.